Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level puzzle, and it's called Absolute Chaos by Fenners. And we've done something very similar to this because I think it was where they introduced yin, yang, and yang as a rule set, but it was also a chaos construction. And I think the rules are very similar actually. Actually, I think they're almost exactly the same. Yeah, all the rules are exactly the same. It's just that the arrows are different. Anyways, let's get to the rules. We have to place the digits 1 through 9 once in each row, column, and 9-cell region. So this is chaos construction too. This is typical chaos construction rule set, where you must construct a nine 9-cell regions, each of which are entirely composed of the same shading orientation. Additionally, each shading orientation, this is where it's different, must generate 3 regions. So each of the shading orientations has to have 3 regions in that shading orientation. We'll get to that soon. But from that, you have to construct 9-cell regions, which must be orthogonally connected to each other because of the yin yang yang rule set. So we have to construct our 9-cell regions. So our 9-cell regions could be something along the lines of like this, right? This is a valid 9-cell region. But we have to divide the entire puzzle into essentially 9-cell regions. And there's no overlap. We also have yin yang yang, where there are 3 shading orientations, light, medium, and dark. We construct a shading of the grid where each shading orientation is orthogonally connected and no 2x2 area is entirely composed of one shading orientation. So you could have, as an example, something like this. Well, let's remove this part and this would be a valid yin yang yang shading orientation, because you would have this is all orthogonally connected to it. It's to from every cell in its region. You can get to any other cell just by traveling through edges. From any cell in this region, you can stay in the region and connect to any other cell in that region by traveling through edges. And same with the blue region. So that's how yin yang yang, and none of the 2x2 areas in the grid contains only one shading. And that's how yin yang yang works. For the arrows, the digits on a tail of an arrow sum to the digit in the bulb. The tail of an arrow has the same shading orientation along its length, but must have a different shading orientation to its bulb. This should actually just not be with an apostrophe, because ITS, the apostrophe is the contraction it is instead of its bulb, which is the possessive. The digit in the bulb of an arrow indicates how many of its shading orientation it can see in its row and column, including itself. So, for example, if this were, say, a 5, it would see 5 cells, different shading orientations block vision. That's important. So if this were 5, it would see 5. It could see 5 cells of the same shading orientation in its. It would see that horizontally and vertically, including itself. So that's how the bulbs and arrows work. Also, the bulb must be the same as the sum of the digits in the tail of the arrow. So as an example, you could have something like, well, if this were 5, this would have to be 5. because the sum of the digits on the tail must equal to what's in the bulb. And all of these are the same or shading orientation, but they must be different from the shading orientation of the bulb. So these would be the same shading orientation. This would be a different one, and that's guaranteed for the arrows and the bulbs. And again, to reiterate, for chaos construction, we need to construct 9 9-cell regions, each of which are entirely composed of the same shading orientation. And each shading orientation must generate 3 regions. So each of the 3 shading orientations must contain 3 regions within it. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so what I found in this was that dividing things up where the boundaries had to be made a lot of help, right? So this has to be a boundary because these are 2 separate regions. So we're going to make this green, and I don't know. I guess we'll make this blue. This has to go this way because it has to have a 9-cell region. We have to have actually 27 cells. So there's 27 blues, 27 greens, and 27 of the last color. We'll probably make it red. This has to be, so this is different from this cell. So this has to be, this is all the same region type. But we know these 3 digits are at minimum 1, 2, and 3. So that means this is at least 6. This is 1 at least, so this is at least 7. So it's 7, 8, 9. But we know this digit cannot duplicate here, right? So the region must not, since there are no duplicates, there are no repeats in the same region. And if this were, it can never be 4 unique digits here. So this digit must be in a different region than at least one of the other ones here. And since they're blocked off by this, because this is a completely different shading than this must exit out this way also. So these are all the same shading orientation. It's likely green would be my guess, but we'll make it pink for now. Actually, let's make it yellow, and this will make pink. This is also, actually, this has to be a different shading orientation because the arrows, again, are a different shading orientation than the bulb. So this must go up this way. These are different. This cannot be the same as this yellow. So this has to be a separate one. So this is a separate orientation here. Remember, as I said, whatever comes out this way has to be a different region than what comes out this way, right? And because you cannot have 4 digits, unique digits, adding up to a single digit, because the minimum for 4 unique digits is 10. So one of these has to be duplicated. Since one of them is duplicated, that means these has to form 2 regions. If one of the regions is, if part of the region is here and this is part of the regions, it still needs to exit out this way. If part of the region is here and this is part of a region, it still needs to exit out that way. So this has to be all part of the same region. It's likely green would be my guess. This is a different region. This is a different region. This is a different region, right? This is a different region here. This is a different region here. And this is a different region here. This then has to be a different region this way. This must go this way then. This is the third shading type. This yellow must continue out that way because there's this is at most 1, 2, 3, 4, 5, 6 here. Hmm. Hmm. So this is at most 1 through 5. We know there's a 1 in one of these. Right? Because these three have to be at most 1, 2, and 5. Because it has to be with 1. This is at least 6, so this is 1, 2, or 3 at most. Hmm. So this is 1 through 8 here. This is 1 through 8 here also. Can this ever be 7? You'd have 1, 2, 3 here. This would be 1. You'd have 2 and 3 here. 2 and 3 here. 1 through 6. Yeah, it's possible still. This digit is the same as that one. Can it be yellow? I don't think either of these can be yellow, right? If this is yellow, yeah, it would have to well, maybe it could go on this long tangent here. I don't know. These are the same. Well, this could be just the same as the only, yeah. These are different from, well, this could be the same if this is different from this. Wait, aren't these two the same digit? Yeah, because both of these go to the arrow here. So these are the same digit. So this is 6 through 9, 6 through 9. We have 1 through 6 here. This is 1 through 6. This is 6 through 9. But these could be the actual same orientation. We're not sure. This is actually not guaranteed to be a boundary. What else do we know? Actually, let's make this the strange coloring shading. Let's make this red. This will make green, and this will make blue. This is 1 through 8 also. Um, technically, I guess this could be red down here. Unlikely. It would have to go. Everything is 27 in size. For this to go, how does that work? I think this has to be green and blue here. Say this was red. I guess you could technically have something like here. Be 27 without a 2x2 area. Seems really difficult. Right? Well, we know this is one region, and this has to be one region too. I think there has to be one that's all the way outside, right? With like little small burst inside. So can this ever be red? I don't think you can, right? Try to enclose they're all 27 in size for the shadings. So if you try to have an enclosing around here, this would necessarily be greater than 27. Sorry, this would have to be greater than 27, assuming the inside part is 27, right? So this can never be red. This is blue or green. This has to be blue or green. You could have a red here. Yeah, the problem is, well, so you can't have red this way, right? So if this were red, it necessarily encloses this. It necessarily encloses this. And therefore, the one would be greater than the other. What about here? Maybe that might work. Um, Or you could be something like even that. This one can never be red because it will always block off the green or it will block off the blue. But this actually could be red technically, right? You could have something like this. And then the green goes around this way. Yeah, that's possible. Yeah, you just need enough space to get the blue and the green and the red out if this were red. But the problem is that would never be the case, right? You can't go this, you have to go either here or here. If you go here and this is red, it just doesn't, this green region will be smaller. If you try to go this way, the same problem, right? Yeah, the blue region would necessarily have to be smaller. But you could do something like this, right? Or sorry, you have to do, well, you wouldn't have to. You could do something like this though. That would actually be valid. Because the green can get out and the blue can get out. Same with this. If this could be red. So this could be red. This just cannot be red here. Um hmm. Hmm. So I don't think this can ever be, well, maybe. One, two, three. It cannot go from here, right? Because that would block things off. But if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is at most 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's one region. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this can never be red. This has to be blue or green here. But this could be red here, right? So this could be green. So we don't know how that works. Right, wherever the red goes in, the green has to go out, essentially, and then cover that part. So the red will always be next to the green here. So it could just be like here to the edge. The blue is similarly that way. The digit in the bulb indicates how many of its shading or okay, so this cannot be 9. It has to, okay, so this has to be 7 or 8. So this is always all green, which does mean, okay, so either this becomes green or this becomes green. Um, hmm. It can never be 9, so this can't be 5. This can't be 3. So this is 1 and 2 here. This is 1 or 2 here. These cannot be 8. This sees 7 or 8. This sees 6, 7, 8, or 9, so it must see the same 5 here. This... Okay, is this blue? Is the question, right? Because it doesn't see any here, it doesn't see any here, it doesn't see any here. This must be at least 3. So it must go down to here. And if since it goes, this is 3 because it adds, it's the sum of 2 unique digits. So it goes down here at least, which means it cannot be green. Because if it were green, then this would be a 2x2 area that's all green. So this has to be red. So we know this is red. That means this must be 9 because it sees 9. This is a boundary in itself. These have to be, okay, so let's draw all the boundaries all around the grid. And this must go this way. This technically could be blue. We don't know which. So this is 7 or 8. This is a separate region. What does this see? It sees 1 at most here. This okay, so this region has to be at least 5 here. I guess it doesn't, wait, it doesn't have to go that way. It has to go at least 3 here. It could be 5 here and then 1 here. That's possible. Actually, it cannot be. If it's 5 this way and then 1 that way. That's interesting. So if it's this blue, it has to be only 6 because this has to be a 9 region by itself. So this cannot be blue, I don't think. Well, it could be if it goes to here, or it could extend here too, right? Hmm. If this is red, though, we have a problem, right? If this is red, this would be 6. It would have to go here, and therefore, well, but it doesn't have to be the same region. Oh, but it doesn't matter. It's orientation, right? Shading orientation. So if this were red, it fails here, right? Because this would all be red. This would then have to necessarily be red because it couldn't be blue or green. So this cannot be red. This has to be blue. This has to be the same orientation as this. Therefore, it cannot block off here. It cannot block off here. It has to be there, and it has to be 6. So this is 6. This has to be 1, 2, or 3, which means this cannot be 1, 2, 3. It cannot be 6. Anytime you have one digit adding up to 3 unique digits, you have to have at least 2 of them from 1 through 3, right? Because the largest one, 9, can be 1, 2, 6, which contains 1 and 2, 1, 3, 5, which contains 1 and 3, and 2, 3, 4, which contains 2 or 3. So since this can never be 1, 2, or 3, or 4 or 5, it can't be 1, 2, or 3. It has to be 4 or 5, which makes these 1, 2, and 3 here. This must be either 1, 5, or 2, 4 here to add up to 6. This C6 specifically, the red has to go all the way around here, which means this is a region in itself. This must be 1 through 4. This C is only 6 because it's these regions, so this cannot be 6. This is a separate region, and it could be part of this orange. This could be red. Well, this can't be the same region here, but they could be the same shading. This C6. That's interesting. This is at least 3. So it could go up. This has to be 4, 5, 7, 8, 9, and these are 4, 5, 7, 8, 9, 4, 5, 7, 8, 9, no 9 here. This has to be a different. Well, this doesn't have to be the same region. Could be a region here and then a region here. Okay, this cannot be 3. Because if this were 3, that would force this to be 1 and 2, and that would eliminate all possibilities for that cell. So this is at least 4 that it sees. This sees 9. This sees 6. This sees 6. It could be these 6 here. This sees 6 at least. Oh, wait, no, it's 4 and 1, 2 at least. So this can't be 6. This has to be 7, which means it includes this one, which means this is all red. So this would see 8 or 9. Because it sees at least here. We don't know about this. This cannot be blue. This cannot be red. This has to be green then. because red cannot be here because we know this sees at least 7 because it's 4, 1, and 2 at minimum. Since it's 4, 1, and 2 at minimum, this has to be 7 at least. It must at least, it can't go see this way. It could see this, but then it has to see this one at least, and therefore this red does not have any other place to go except for here. Therefore, this must be part of the red region. So this is 8 or 9. This is green then. That's interesting. This is a different orientation and it cannot be red. This must be green also. So this is all separate region. Since this is green, this can never be red. This has to be blue, essentially. The blue eventually has to get over here, right? I guess it could be here. That's possible. Yeah, blue could enter in this way. That is true. This digit is the same as that digit. This cannot be red. Can this ever be red? We have 9, 18, 1, 2, 3, 4, 5, 6. So this can never be red here. Right? It can How can it get to there? It can't be part of this and then be part of that. Well, first of all, it can't be part of these two. So this is not red. This has to be a separate orientation. We don't know which one that is, though. If we try to make it red, it would have to go around here, which would be too many. So this would be 6, 7, 8, and 9 it could get to. So this is blue or green. We're going to mark that as pink. This is orange. Can you go this way? Possibly. Could be orange. Could be pink. Either one works. So red can go here potentially. If that's the case, blue has to go through this way. I mean, guess it could be, like something like that. Or it just goes all the way here. Right? This is a separate region. None of these can be red. So this has to be the orange, right? Because if it's pink, well, no, it could be pink. It could be pink as long as this is not pink, right? It just can't be red here. Uh, hmm. This blue can only go 4 this way. And it can't go here, it can't go here. So it must go at least 2 this way. Um, hmm. So this is separate. Mm. This must be a separate region than this, right? Either this is part of either one of these is one or two. This is obviously one, two, or three. So these have to be separate regions. So one of the regions goes this way, could be like this or one, and the other one has to go this way. Um, we don't know what that restriction is though. This can see up to 9, right? No, it can't be 9. If it's 9, this would be green and it would see all of these. Actually, can this ever be green? If this were green, it has to be greater than 4. So it would have to be at least, I mean, it has to be 4 at least. It would see at least 4 here, and this would all be green. So that's not allowed. This has to be blue. So this is blue, which means this is green because it can't be red. Therefore, it sees 4. It could be 4 this way. Could be 4 this way. This is green inside. So this is another region. This cannot be the full 8, because if it's full 8, this is not a region by itself. So this is 4, 5, 6, 7 as possibilities, which makes this 1 through 6. This then has to be a separate region here. We don't know which way it goes. Can this be blue? No, because if this were blue, it sees 1, 2, 3, 4, 5, 6 at most. I guess it could be 5, technically. Oh, wait, no. If this is blue, this has to be blue, right? I guess it could be this way, and that's 4? Maybe? Hmm. Interesting. So if this is blue, it's blocked here. And it cannot be 6, so it can't be the full blue and the full blue here. Because that would be exactly 6. So it could be 3 even, I guess. It could be 3 or 2 technically. And this would be green. This would be green. That's possible, I guess. Hmm. Otherwise, green is much less limited. Um, can this be the full blue here only? And the answer there, I guess it could be. This could be green and green. This would be 6. Yeah, technically that could work. So this green has to either go out this way, has to be part of this or part of this. We don't know which, right? Well, I mean, these two are different, right? Hmm. I'll always remember us this way. Huh. Oh, that's interesting. So if this is 8, that means these all have to be red, which is not possible, right? Because you have to have a 9-cell region. This would then be double. So this has to be 9. So this has to be 9. It has to go to here. We don't know if it continues on there, though. It could be 2, 3, 4. That's fine. It could go here and here. Or just here and here. Hmm. Could be just 2 here. So the red can go any of these 5 cells. It cannot be this one. These two are different. um, this cell is the same as this one. Oh, this is interesting. If it's green, this cannot be green. I guess this could be green here. What is this? So if this is, okay, if this is blue, it has to be less than 6. If this is green, I guess this could be green here. But this could not close off the blue. So it could be one. This would not be green, obviously. I guess This would have to be blue. I guess it could close off that way, technically, right? So it could be 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 at most. No 6. 7 or 8 here. If it's blue, it's less than 6. Technically, it could go here and then. Oh, that's interesting. Say it went just here. If this is all blue, this has to be blue. I guess it could go here. Hmm. So if it does go to here, if it reaches here, it has to go. Obviously, this is all becomes blue. This can no longer be blue. This is green, which would force this to be blue then. So you'd have blue going that way. So we're trying not to connect here, right? More specifically going that way. So if this is blue, this would be blue, this would be red. This could not be blue because so this would have to be red, this would be red. So then this could not be blue, this would be green, so this would have to be blue here. So this would be blue, this would be blue, this would be blue. This could not be red here. The problem is green could not block this way, right? This has to be blue all the way next to the red. Well, not all the way. But if it goes this way, it has to go all the way to the red with the red here, right? And so if this becomes blue, that would be blue. This would technically be blue then, and that could work. So then the blue could go around here. That would be fun. This would be green. So you could have something like that. Going all the way down. This would be green, so this would have to be... One of these is blue, one of these is green. That's actually very interesting. So we have a blue-red-green mix. That... Could it be both blue? Maybe. So that's not guaranteed, actually. I mean, this could be even blue here, and this is 4, right? That's possible. um... So if this is blue, this has to continue as blue here, right? Well, okay, if this is 6 and this is blue, this becomes blue. This becomes red. This blue, this makes this green, which would force that to be blue. Can this ever be blue and this is green? If this is green, it must connect some way here. I guess it could be red here, and this would be green. So be blue. If this is blue and this is blue, one of these two must be blue. If these three are pink, that means this is pink, this cannot be pink. But then this would also have to be pink if that's the case, right? If this is orange, obviously it would not be the same as that one. Hmm. There's no restriction there then. If this is full 6, this would obviously be the same. This would be different. This would have to have something, at least one going this way, because this would be cannot be the same digit. You could have blue going that way, and this would be 4. You just cannot have it connecting that way. Hmm. Okay, so hmm. If you had blue here, this would have to be 4, right? And then say we had this be green. This would then be blue. If this is, well, it could be blue. If this were blue, okay. Hmm. So this would be 4 because it could not go down here. This would all be green. So this would have to connect this way, which would mean this is blue. It could connect here. This would have to be green. So we tried making that green. That forces this all to be blue, to be 6. This would be green, this would be green, so this could not be green. This would have to be blue. Hmm. This would then have to be red, red. So that's possible. Hmm. So that was if we made this red. Sorry, green. If this were blue, this has to be green. Hmm. There doesn't seem to be any restrictions there. Oh, that's interesting. Okay, so let's make this green. Let's make this blue. That would make all of these blue. It could not connect this way because then that would be 6. So these would have to be green. This would be 4. This would be 4. So this would be 1 and 5. This couldn't be 1 or 4. This couldn't be 1 or 4. This is 2, 3, 2, 3. This is 1, 5. None of these could be 4. This would have to connect this way. This would then be green. None of these could be green, so this would be blue. So this would be set of 9 here. This could technically connect this way. This would be red and red. This could not be 4, and it cannot be 6 because that would, well, it technically could block that off. So this would be 5 or 6. Which means this can't be 6. This can't be 4. This can't be 4. That would leave this as 6, 7, 8, 9. This is 5 or 6, so this would have to be blue. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So that's possible. Interesting. So this would be 1 through 4 here. This would be 1 through 4 because they would only see 4 greens at most. This still feels feasible. This could connect this way. It cannot be 9 anymore, though. So far, this is looking fine. Oh, doesn't this have to always be 3 here? I think so, right? It doesn't have a 6. It has to be 4 or 5 to add up to 9. Yeah, I think it has to guarantee to be 6. Sorry, 3 here. There has to be a 3 in one of these two spots. Again, this cannot be 7. Or sorry, it can't be 8 because that would block this whole thing off. But it could be 7. What happens if it's 7? If it's 7, then this is all blue. This has to be green, which makes this a blue. So then this would be blue here, which means this is green because it can't be red. Therefore, this is blue. This has to be green, which makes this a blue. So this cannot connect this way. This has to be green here. This has to be green here. This must be blue. So we have 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21, 22, 23, 24, 25. The problem with this is we only have 2 more blues. The reds have to be here. We only have 2 more blues. This is green. This must be green then. This has to connect this way. So this is green, which means this is blue. I guess that does actually work. Green, green. This can't be blue. This has to be green, and then this is... That does work, actually. Huh. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7. So that does work. This would then be 5. That wouldn't work because this would be 5 and this would be 5. Because this sees 5 blues, this sees 5 greens. So that would not work. If that were... So this cannot be 7. Could it be 6 is the question. Maybe. I mean, technically it could be 6 that way, right? Um... Oh, that's interesting. So if these are both green, this has to be blue. Otherwise, this is blue. So somehow the blue must either go here or go here. That's interesting. If the blue goes here, that means the rest of this must be blue until it gets to red. Because the green, well, maybe not. No, yeah, if this is blue, how does it connect to the rest of the blue? It cannot go this way. Because the green would have to go this way, right? And then this would not be able to connect. So if this is blue, if this is blue, it has to at least go that way, right? Hmm. Um. Okay, let's go back this way. What happens if we make this all blue and this is green, which would make that blue? That's actually interesting. Hmm. Then this would have to be 4. Actually, it could be less than that. Okay, we'd have green here. This is blue. This is blue, so this would have to be green, which would force this to be blue. So this would have to connect this way. This would have to connect this way. This would have to be something else, not blue. So this is red. This is red. That's 9 red. So this must be blue or green. But this is essentially blocked off. Could not be green here. This would be 5 then, which would force that to be 4. This would definitely have to be blue, which would force this to be green, this to be green, which would make this blue. So this would have to connect that way. This would have to be blue. This would be blue. This green has to connect somehow, so it has to connect this way. Right? There's no other way to connect it. This has to be blue because anytime you have a yin yang and you have two on opposite sides, that requires this to be and then we have a contradiction because this has to be at least 4 and it cannot go to here. So this cannot be, I mean, it can't go 6 all the way here. So it must go here. Okay. So then these are separate regions, we know. This has to be a separate region than this, so this must extend this way, which means this does not. I guess it could connect here. This is a separate region, because this has to be a separate region from this, because we have a duplicate here. One of these is 1 or 2, and this is 1, 2, or 3, obviously. But we can't go all 6 this way. We've just shown that. What if we try this as blue, right? This could be 5. This is a green. This cannot be green. This is blue. This green can only connect this way. So this can't be blue. This would be green. Would have to connect this way because otherwise there's no other way to connect. This could be 6. This could be 5 here. Oh, this has to connect this way. So it has to connect here. These then become both reds. This has to be blue because it's opposite of this one. Since this is blue and this is blue, this has to be blue. So both of these at least have to be blue. It cannot connect. So if we did 1 here, that would be 6. So this would have to be 5, which would make that 5. This would be 4. This would have to be green because it cannot. Wait, then that already fails. Okay. So we tried going without that being blue. But if that's not blue, this has to go this way to go here. This is 3 blues, which would make that green. Therefore, this would be blue. The only way for this green to connect would be there. Therefore, that would be blue, and this would be blue then. So this is always blue. Which means this has to be blue, because otherwise this wouldn't. You'd have a green. If you try to have green here and blue here, they would break apart the other region. So this must be then green, which forces this to be blue. This again must be a region by itself, so this has to be green. So this is blue, this is green, this is blue. This could be 6, we don't know. This is 4. So this is 4, this is 4, this cannot be 4. This is a 1-5 pair, which means this can't be 1. This can't be 1 or 4. It has to be 2 or 3. This can't be 4. So this has to be at least 5. So it goes here, which means this can't be 6. None of these can be 4 here. The rest of this is 6, 7, 8, 9. This can't be 9 though because of this 9. This blue has to form a region here, so this becomes all blue. Therefore, it must connect out here, which means this is blue. So this is not orange. This is green. This is green. This must be all blue because it must be the same region. This must be red. Therefore, this is a separate region. This must go out this way. This must go out this way. So this has to be green. So this is green. This is green. This is 1, 2, 3, or 4. Obviously, this can't be 3. This can't be 3 then. So this is specifically 2 or 4. If this is 2, this would have to be 6. So it can't be 2. This has to be 4, which makes that a 4, which makes that a 5. This sees 4. So we see 1, 2, 3. 1, 2, 3, 4. 5, 6, 7, 8. So this sees 8. This has to be 1 and 3. This must be the same region, so this must be 2 and 6. Because it sees 1, 3, and 5. This is 2 and 6. This can't be 6. This can't be 8. This can't be 8. No 5 either. No 5 or 8. This can't be 4. This can't be 4. We have 8 and 4, so this is a separate region here at least. This can't be 4. One of these is green, the other is blue. We're not sure which is which. This is a separate region. This is a separate region. Same here. Same here. Sees 8. This sees 4. This sees 6. Okay, so this is at most 1, 2, 3, 4. Okay, one of these has to be green. The other one has to be blue because this has to connect somehow. This could be green. So it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So this is 22, 23 at most, so this must be green. Which means this is an 8. It cannot be 2 then. 2 and 6. This is 8, so this can't be 8. This can't be 8. This must all be part of this region. 1 and 2 has to be here. This is 7 or 8, but it can't be 8. Therefore, this is 7, which makes this 7 and 2. This digit that's not in this column is a 2. Actually, that's not true. We don't know. This can't be 7 here. This just can't be 2, which means this can't be 6. This can't be 7, so this is 4, which means this can't be 4. So this is 1, 2. This one has to be blue then. So it connects that way. One of these cannot be blue. And it can't be, so therefore we have to have at least a green. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So this must be green. We have okay. So this is 1, 2, 3, 4. Okay, this cannot. This 1, 2, 3, 4, 5. This is 5 actually. We already know that. So this has to be 2 and 3, which forces this 2, 3 pair eliminates 2 and 3 here. So this is 1. This cannot be 1. We have 1, 2, 3, 4, 5, 6, 7, 8, and the last one is one of these two. So that's 9 because it cannot both be green. So this is 9. This is a region. We have 1, 2, 3, 4, 5. Okay, so this is both 2 and 3. Therefore, this should be the end of a region here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a region there. So this is 6, 7, or 9 here, but it can't be 6 or 7, so this must be 9, which makes this 6, which makes this a 7. This can't be 6 or 7, so this is 8. This can't be 6, 7, 8, so it must be 9. This can't be 7 either of these places, so this can't be 1. These can't be 5, so these can't be 3. This is 4 and 4. The rest of this is 7, 8, 9. 9 cannot be here, therefore 9 is here, which makes this a 7, 8 pair. That leaves this as 2 and 6, and this 2 eliminates 2 here, so this is 6, which makes that a 2. This can no longer be 2. Wait, that's a fail. Where did I mess up here? Dang it. I don't know where I messed up. Oh, I see. Here. This doesn't have to guarantee this one because this is not necessarily all the same region, right? So this could be 1, 2, 3, 4, 5, 6, 7, 8. This just can't be 8. This can't be 1 then. But that's pretty, yeah, pretty broad. So this can't be 4, this can't be 5. I think it's all the same though. So this one actually does have to be the same. This is, we have 1, 2, 3, 4, 5, 6, 7, 8, with one of these being 9. So this cuts it off here. This has to connect this way. This is a 5, which eliminates 1 and 5 here. So this is 2, 3 pair, which makes this a 1. This can't be 1. This has to be 7, 8, 9. This must be a 9. So this is a 7, 8 pair here. This cannot be 2, so this must be a 2 here, which makes this a 6. So this is a region. Again, this is a full region. So that's good. Which means this has to be all green. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Which means this is a region. This can't be 6, so this must be 7 or 9. One of these is a 6, so this can't be 6 here. This cannot be 2 and 7 added together. It's 1 and 8, 3 and 6, or 4 and 5 here. These cannot be 5, so these can't be 3. This is a 2, 3 pair. 9 cannot be here. Remaining digits in column 1. No 1, 2. Could be 3, 4, 5, 7, 8. No 4, 8 here. No 5, no 4 here. 9 cannot be here. Where is the 9 in this region? It has to be one of these two, which means this can't be 9. This is 7. This is 6. This is 9. So this 9 means this can't be 9. We have a 7, 8 pair here. 8 cannot be here in this region, so 8 has to be one of these 3 digits. One of these digits is a 1. There has to be a 1 in this 9-cell region. So the rest of rows 8 and 9 cannot contain a 1. So this can't be 1. This is then 3 and 5, which means this can't be 3 or 5. This is 1 or 2. This is 1 or 2, right? Because this is 1 and 2 and this is 1 or 2, this can no longer be 1 or 2, and this can no longer be 1 or 2. This can't be 3 because of that 3, so this must be a 4, which makes this a 4 because otherwise there's no other digit in that region that can be a 4. We have a 7, 9, 7, 9 pair, which eliminates 7 and 9 in the rest of the column. So this can't be 7. This is a 4, which means this cannot be 4, 5. This can't be 3, so this can't be 6 here. This is 4, 2, and 1 plus 8 plus 1, which makes 8. So this is 1, this is 2. None of these can be 4. This can't be 3 because of the 2, 3 pair here. This 1 means this can't be 1, so this is 3, this is 6. This has to be a 2, 6 pair, but this can't be 6 because of this 6, so this is 2, this is 6. Okay, this can't be 7, cannot be 7 because of this 7. What digits are remaining? 1, 7, and 8 in column 3. It must be 4, 5, and 9 in column 2, but this can't be 9 or 4, so this must be 5, which means neither of these could be 5. The remaining digits in this region are 1, 7, 8, which leaves this as 2 and 5. This can't be 2 because of the 2, 6 pair in the column, so this is 5, which makes that a 2. The remaining digits are... this has to be 4 and 5 because 4 and 5 cannot be in the rest of this column, so this is a 5. Remaining digits in row 8 are 2, 7, 9, which eliminates 7 from the rest of the region. So this can't be 7, this is 8, which makes that a 7. That leaves this as a 1, 4 pair, but this can't be 1 because of this 1. So this must be 4, this must be 1, which means this can't be 1, this is 3, this is 1. This can't be 2. This is 7 or 9. This is 7 or 9, which leaves 3 and 8 remaining in the bottom region here. This 4 means this can't be 4, so this must be 9, which makes that a 4. The rest of column 9 is 1, 3, 6, or 8. This can't be 1. These can't be 1. This can't be 6. This 1 means this can't be 1. Where's the 1 in column 3? It has to be here. So this can't be 1. Where's the 1 in column 9 then? It has to be here. This can't be 5 because of the 5 there. Remaining digits, well, in the blue region in the middle, it has to be 2, 3, 2, 3, 7, 8, 9. And this can't be 2 or 3 because of the 2, 3 pair. This can't be 3. This can't be 9. This can't be 6. This can't be 6. Where is the 6 in row 5? It has to be here. So this is 6. That means this can't be 6. What is rest of row 3, 2, 3, 6, 7. But it cannot be 2 or 3 because we have a 2, 3 here. Therefore, this must be a 6, 7 pair in the green, which eliminates 6, 7 in the rest of the row and the column. So this can't be 6, this is 2, this can't be 2, this is 6. This can't be 7, so this is 3. This can't be 7 because it's the same region, so this is 9. That leaves this as one of these is a 5. So the 5 has to be here, which makes this a green, which makes this not a green, so this is blue, which means this is 2, 3, 7, 8, and 9 here. This 5 means this can't be 5. We have a 7, 8, 7, 8 pair now in column 1, which eliminates 7 and 8 in the rest of the column. So this is 5. This 7 eliminates that 7, so this is 8, which makes that 7, which makes that 8. This can't be 8, so this is 3. This can't be 3, so this is 2, which makes that a 3. This 2. The only digit remaining here now is a 9, so this can't be 9 or 8. This can't be 9 or 8. This can't be 8. So this is a 7, which makes this 8, which makes that 7. This becomes a 2, 3, 2, 3 pair. This 6 eliminates 6 here, so this is 7. This is 6. This 2, 3, 2, 3 pair eliminates that 3, so this is an 8. This can't be 7, and this can't be 9. This 1 eliminates that 1, so this is 5, this is 1. Neither of these can be 1. The 7, 8 pair eliminates that 7 and 8, so this is 1. This 7 eliminates that 7, so this is 8, which makes that 7. This 8 eliminates that 8, so this is 3, which makes that 8. This 3 eliminates that 3. We know this is a region in itself. So this must be 2, which makes this 3, which makes that 2, which makes that 3. This 2 eliminates that 2, so this is 9. This has to be 2, and this must be 7, which makes that 9, which makes that 7. Ooh. Yeah, this assumption was bad. But fortunately, we found it fairly quickly. Interesting use of these arrows, right? So I tried to use arrows here, and I kept coming up with issues, right? So it was specifically the bulbs, I think, that were making it useful to restrict. So pretty cool, pretty cool. Definitely hard, but you know, not too bad. Chaos construction rules do tend to do take a while, and it's not for the faint of heart, I would say. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.